Hi, my name is Annie and I'm working in AI since several years in manufacturing, in production, in quality, in supply chain, in sales, marketing, and of course R&D applications. And it's a real pleasure for me telling you something about how to use AI in future-proof machine designs today. First of all, I would like to know how you are using AI. I'm pretty sure most of you are using AI, for example, in their daily lives. Maybe they are planning their holidays with ChatGPT, or maybe you write emails with the support of Copilot. Maybe you build your first own AI agent with Copilot Studio, or just beside all the Gen AI topics, there's of course also the classical AI, where we are thinking about predictions, for example, in your production, quality predictions, or classifications and topics like this. But if we are talking about AI at the moment, we are mainly talking about several AI use cases. And AI itself is nothing really new. It's first mentioned in 1956, so almost 70 years ago. And still, as you can see here in the AI hype cycle from Gartner, this is something where we need to say it's still a hype, what you can see here in the slide deck. So why we are still talking about AI after so many years in the relation of a hype? The answer is pretty easy, because the power consumption is much higher than ever before. Microelectronics gets further developed. So we have so many things that developed over time that really enables what we can do today on AI. And as you can see here in the hype cycle, there are different expectations on different parts of AI technologies. And you can see the plateau of productivity just on the right-hand side, where you can see computer vision cases. I guess if you already implemented something in your production or quality assembly lines, then in the most of the cases, it's about the computer vision. And there are plenty of solutions already just ready to use, available on the market. And of course, there are others, maybe much more on the peak of inflated expectations, or maybe a little bit behind, so down to the valley of disillusion, because first, when some new hype, some new trend in AI came up, everybody thinks, oh wow, this is now the moment where all my problems I was never capable to solve it before, to solve it right now. Of course, it's not like this, unfortunately. But nevertheless, many problems will be possible to use, and we just need to understand which technologies we need to use for which use case. And as you can see here, we will also further talk about robotics a little bit later on, and of course generative AI, foundation models, and so on. But first of all, I want to show you with one example how powerful generative AI already is. As you can see here, we ask Google Gemini, but we also did it with ChatGPT, with DeepSeek, and some other large language models. And we tried to find out how capable they are to identify the defect on this woven fabric. And we were very impressed about the results, because we asked, if you don't see any defect, as you can see in this black box, if you don't see any defects, it's fine. If you see a defect, please categorize it in one of the 26 categories you can see here. And the answer was, yes, there is a defect in the attached close-up textile fabric image. The defect is a stain which is listed as number 18 in your provided list. That was one prompt, one picture, so we call it zero shot. It's just the information that's there and it's 100% correct. To give you an understanding, what does it mean? In the past, with classical approach, we needed around 1,000 pictures of a defect for each category. We have 26 categories here to identify the same result. So it depends on the use case, but if it's the right use case, LLMs, Gen AI, it's really, really powerful. But if we are talking about AI, the biggest challenge, in my understanding, is maybe not the AI itself. We have so many very capable people out there who make so stunning things with new tech insights on AI. But the most challenge that the most people don't have in their mind is the customer. Because what is happening if in the personal lives from all of us, so many things are changing? For example, if you ask ChatGPT when you want to buy a new heat pump or something like this, just within seconds you have thousands of information available, benchmarks with other competitors, transparent parameters. So the information, the knowledge is just there. It's nothing where you need to go into a shop, where you need to get insights of any sales or marketing manager. You just have the information available. And by doing so, there is a knowledge shift. And that knowledge shift let us come to a point or to a question where we need to ask ourselves, what do you sell to a customer who knows already everything? In the first step, it a little bit sounds like, oh yeah, that's a sales question, so please ask the sales department. But to be very honest, the heart behind and the secret behind and the answer behind is in machine design. Because machine design will be the answer that makes us much more modular, much more flexible, that give the machine the opportunity to be much more data capable, upgradable with software updates over the air and topics like this. And this is something what we will need to further improve in machine designs. So, what does it mean? That means that AI is not a buzzword anymore. AI is really disruptive for all of our businesses. And it's not just about which AI use case we could implement to maybe improve our activities, to improve our productivity, and so on. It's a bit bigger picture. But nevertheless, it's always very important to have a benchmark which use cases are available out there. And together with our Turkish cooperation partner Next and the World Economic Forum, we made a study where we identified plenty of manufacturing use cases on AI. So please feel free just to make a photo of the QR code, and then you can deep dive into different use cases. But of course, during our session today, I will also give you some examples later on. Long story short, AI is not a buzzword. AI is not something a term that's using the sales and marketing department. AI will be at least so disruptive as it was the internet 30 years ago. 30 years ago, nobody had in his mind that it's just normal to have a company website. That was something really special, and everybody was wondering, I'm not sure if we need to have that, but maybe it's good that somebody can find us. Today, it's just there. Nobody would ask you if you give your presentation or your information, your research results, oh, did you use Google? Because of course we used Google, right? But today everybody's asking, did you do it on yourself, or maybe did you just ask ChatGPT? Because it feels a little bit like you do something that it's not allowed, like when you were at school and you were writing what your neighbor is writing and you're looking there, right? But this is a mindset shift. That also needs to have different competences on our side about prompting, about how to validate data, and how to create something really impactful out of what we receive as a result from the AI. So, if we go with this way of paradigm shift, let's think about how the shift will look like. Here we can see that AI will be the operating system of our machines. What does it mean? That means today, if we are talking about machine designs, we are doing that very component related. So it's about PLCs, about sensors, about actors, and we want to ensure that it's really precise, that it's really repeatable, that it's our reliable backbone. But in the future, the machine will be much more intelligent. So it's not just about electronics behind, it's about how to create an adaptive and data-driven system. And that will be in the future not anymore just be programmed, but trained. So if we have this in our mind, we need to understand that for the machine design in the R&D departments and so on, we need to add total new competences to have all these developments in our mind and be able to integrate this way of thinking into our machine designs developments. Here in this video, you can see one of our examples from our AI and robotics lab in Hong Kong. It's called FLAIR. And here we were working in injection molding and tried to combine quality and machine data to make a prediction how the parameter setting of the injection molding machine needs to look like if we want to know that the outcome, the result after the injection machine finished their work is exactly in the way we were expecting it. Why is that needed? There's not just technologies like AI on the market that are revolutionizing us. There are also market trends that changing expectations of customers and the users. And one of these market trends is, of course, sustainability. And if we are thinking about circular economy, about recycled materials instead of virgin materials, this becomes really, really important. Because if I have my virgin material, a very good worker will be, of course, able, based on his knowledge, to just adapt the parameters on the machine in the way that the result will be fine. But if you have, instead of the virgin materials, recycled ones, the mixture of the materials will be always a little bit different, but so much different that your results are not in your range of your quality expectations. So you always need to adapt a little bit in the one or the other way. And through AI, you can predict that, how the optimal parameter setting will be. And this is one possible use case, how we can improve these issues. It's not just about how an operating system will look like, it's also about that AI redefines the way how we are building machines and for whom. So let's start first with the way how we build machines. Today, if we build and create machines or products, so the designer is making the design with the CAD data, and then it's getting stepwise to the next steps, so the preparation of future production steps and so on, to check if it's possible to produce it like this, to assemble it like this. And in most of the cases, over the time, over the process, we identify that, no, it's not working in the way that the designers thought that it's possible, so we need to adapt, we need to adjust. And we need to adjust in a way that we also need to adjust, of course, the CAD construction data itself. That means we go the whole way back and again asking the designer to make some changes and so on. So this is very time consuming. And in the future, it will not be needed to have that huge time efforts for these tasks. It will be like this, as you can see it here, as we did it, for example, with that gearbox of Johnson Electric with our software AssemblyWise, where we combined CAD data with AI to predict how, for example, the assembly will be later on, so that the designer can already include this knowledge into the design process from the first moment. But it's not just within the design itself, it's also about how you are how you are dealing with change requests. And if, for example, you have thousands of change requests every year and so many engineers who do nothing else than just check what is the impact and the influence of that change request to CAD data, to work instructions, and so on. This is really much effort and so much workload that it's not necessary to do that. But that workload will increase because based on AI, the people want to have more individualized product. So we will come into a phase of hyper personalization, and therefore we need to get support also on that topics. And this is also something that is possible if you combine CAD data and AI. If we are thinking about for whom we are designing machines, we also come to the point that maybe the end user is not just the only one who is using our machine or our product in the future. During one of my last presentation, somebody said that he is making machines and the user are animals. Also, for this case, it's the same way, like if you are thinking about maybe the user of a machine, a robot or something like this. This is exactly the same way of thinking, because you totally need to rethink what does it mean. You will have completely different interfaces. You will have different requirements on flexibility, how modular your machine needs to be, because the way how a machine is treating your machine will be different than a human is doing it at the moment. So also these things we need to have in our mind if we are thinking about future-proof machine designs. And I would like to give you also, if we are talking already about machine-machine collaboration, some insights about humanoid robotics. because humanoid robotics, it's something that the people thinks, oh, this is amazing, this is really, really cool, because this is something new. And there are others who feel so much fear if they just imagine, I need to work somehow with a robot and the robot looks like a human. Why does it look like a human? And so on. And nevertheless, it will be as it will be, because the technology is just capable to do that. And as you can see here, this is Apollo from Mercedes. This is a robot, and the biggest change between common robots in production lines and the humanoids, or the Apollo one that you can see here, is that robot is able to work in the same area that the human is able to work in. So you don't need to have a specific infrastructure, so like a cave, where you put the robot in and nobody else should go inside if the robot is working. So the interaction, the collaboration of both, so human and machine, is much more easy by that way. But if you ask us, what is important if we are talking about humanoids, it's much more than just looking like a human, maybe because of flexibility and working in the same environment like a human. It's about thinking, it's about adapting things you know to something that you not know so far, and that you maybe just not tried so far, so like a human is doing. And this is something where we are not there at the moment, but where the developments will go to. So to understand how the brain is working and to teach the robot to really think and adapt by using simulations that needs to work very quickly, that it's not like, okay, he's standing 1 hour in front of it because the simulation is running, that it's really a process like a human would do that. And if we talk about the interaction of humans and machines, we need to recognize that also we as a human need to change. Especially if we are talking about Gen AI topics, we need to validate, we need to become a trainer, a navigator, to really create an impactful outcome for the topics we are questioning and challenging with AI. And if we as a human needs to change, we need to experience how the future will look like, how new use cases will be capable and able to integrate in our productions, in our R&D departments. And that was the reason that a few years ago we developed, together with our close partner Next in Istanbul, the worldwide biggest I4O and AI demonstration factory, where you can see here the assembly of a gearbox. So you can see the assembly steps of a discrete production line, and of course also a virtual way of a steel production to also simulate continuous production topics. So we trained over the years more than 30,000 people within this area. And if you wasn't there so far, so please feel free and please feel very warm welcomed to just go there and experience how the future of AI for manufacturing companies will look like. If we are talking about these topics, we also need to have in mind that different machine designs will have an impact to our business models and the other way around. So there will be totally new business models coming up because we have more modular, more connected machines, and so we know much more about the user, and even the user is expecting much more from us, and also the way how he is cooperating with us. So business models like product as a service or just intelligent add-ons will become normal. So the question is, what's holding us back? And there are plenty of reasons for that, and you can see that here on that slide. There are many pitfalls we saw in several projects that we did in the past, and I would like to give you some insights that maybe you can use this to have it in your mind when you are implementing your AI initiatives and projects, that you hopefully will not do the same mistakes. So first of all, we have the AI theater. What does it mean? That means that many companies, unfortunately, just do AI to make the marketing out of it, just to show, yeah, we are doing something on AI with this and that use case. Unfortunately, the result out of this is a use case graveyard, because if you just have some isolated POCs, that will never scale, and then it will just die. And this is really a pity, because that also makes something with your colleagues, with your employees, with your management, because they think that this is the result out of a general AI project, so maybe nothing or not so much. And that shouldn't be the task, that shouldn't be the case, and that's why you should take care of that you are not creating an AI theater. The second point is that very often AI is stuck in incremental mode. What does it mean? To understand that a little bit more clear, we need just to jump for a second into the innovation theories. There we have 3 different innovation horizons. So the incremental horizon, this is horizon 1, and this is very strong connected usually with the business units. So here we are talking about what's the ROI, what's the business case behind a use case and all that stuff, because you want to become better as you are in the moment with a specific task or with a specific use case. But if you are just focusing on these incremental topics, then you will never change in the whole. So in a way you need for that huge paradigm shift that is in front of us based on AI. That means that you need to also focus on adjacent and radical innovations in the Horizon 2, and of course also the disruptive things in Horizon 3, because you need to reinvent yourself, if not, others will do that. So to stay competitive, this is really essential. And then you need to have the management buy-in, you need to have the strategic wish. It should be like this, even if there is not an ROI within 1 year or something like this. Another topic is the AI database. If we are not talking about generative AI topics, but about classical topics where we are working with structured data, for example, your machine data and stuff like this, or your process data, then you really need to work with it and you need to trust this data. What is happening very often? I want to show you this with this little example. I'm not sure if you know Frank Rosin. He is a German chef, so he is cooking pretty good. And it doesn't matter if you know him or not. It's just important that we understand that he is doing his job, cooking food and making cakes pretty good. So imagine you would put this person into that poorly equipped kitchen. And it's not just that it's poorly equipped, but you can see some white boxes over there. And in one of the boxes, there's written down salt, and on another one, it's sugar. Imagine if the ingredients are the other way around than the labels. So the cook can be as good as he wants to be. He could be an absolutely expert, but the result will not taste good anyways. So what I want to tell you by that is you can have the best AI experts in the world if you don't have the right data, if you don't have the right infrastructure or the right labeled data, then it will be very hard to really scale AI use cases and become a company that is driven by AI into the future. Another topic is ownership. Usually, many companies, they just announce, we are working on AI now. But if you just say it like this and there's no ownership, nobody who is really responsible for some task, for results and so on, then it will not work in the way you want to have it. So please take care to really have ownerships on the topics. And if we are talking about humans, we also need to have in our mind that we're not just talking with the ones who are very engaged because they like the developments that are just out there. They are, of course, not just early adopters, they are also late adopters, or the so-called laggards. And we also need to bring them on board and we need to keep them on board. And for doing so, we need to have a really good communication. So this is implementing AI is really like any other big change process. This is something where every business function needs to be integrated. This is competence-wise HR, this is communication-wise, marketing, sales, R&D-wise, the machine and product designers, and so on and so on. And if you look to the skill topic, we are not just need to recognize we need some people who are able to deal with data. Also, the ones we already have in our companies needs to become more capable in AI and digitalization topics. And here you can see the latest Future of Jobs report from the World Economic Forum from this year. And here you see how the capabilities and the skills that are needed for a future-proof company will change. And last but not least, of course, I already mentioned that need to take care that it's not just bottom up, but also top down. You need to have the management buy-in. Of course, you can implement separated use cases, bottom up, but to really scale AI, you need to have the management buy-in, you need to have the top-down approach. So, this is all I want to tell you, and what is very important, you will not win with AI, you will just be able to win with what AI enables you to build. So please have this in mind, and it was a pleasure for me giving you my insights today. I'm looking forward to connect to you, and please feel free to connect with me. Thank you.